Okay, so going to discuss the rationale for the validation process, what we call the validation pipeline, the organization of these studies, and the initial results. Okay, so I wanted to, discuss with you really the scale of this work. So in a former life, I was in charge of the validation for the International Wine Organization, and we did lots of studies, but I don't think we did anything on the scale of what's been happening within OLEUM within what is a relatively short period of time. So I just thought I'd give you some of the numbers so that we've validated, formally validated by interlaboratory trial, eight methods. That's 7 methods with 1 method has 2 variants on it. Looking at over 20 reported analytes. By analytes, I mean what the actual labs had to report, not what the individual analytes they had to measure, which is a lot more. There was the number of actual participating laboratories with 94 that were in, some of those are from the same institute, but that's the overall number. Over 1,000 samples were sent to participants, and they reported over 5,000 pieces of results, and that does not include the metadata that we asked of them. And we are still looking at a lot of that metadata as we speak. So, formal validation, why do we have to do it in such a large international scale? Well, I think Mercedes yesterday from the IOC suggested why this has to be done this way. It's because the methods have to be used for official purposes by enforcement labs, but also, of course, by the industry that are going to provide some of that or check some of those products. So they need to be robust. They need to have confidence in the results. They need to be fit for purpose because these are routine laboratories if you're going to use them. And they have to be internationally recognized. And to do that, they need to adhere to internationally agreed protocols. Just to give you a flavor that we're only looking at some of the methods that were developed in OLEUM, and these are the ones which are suitable for official purposes, but there obviously OLEUM has been looking at a whole range of methods for authenticity, health claims and quality parameters, and some of those, as Julia has already said, have been published. And they were developed in years 1 and 2, and they've undergone in-house validation in years 2 and 3. So that they've already gone through a procedure before we get to the formal validation. So in terms of the methods which were sort of candidates for formal validation, they were already standardized in terms of the method format through ISO 98-99 and also through a formal in-house validation that we sort of demanded of them. Those candidate methods then went to a pre-trial where we look at sort of initial estimates of performance and get feedback from the participants through various technology transfer workshops. We then, from that, we inevitably revised the SOP, and then, and only then, do we then go forward to the final phase, which is what we're really talking about most of today, is the trial. There is a trial where we have at least 8 laboratories, 10 test materials, and we form the study to internationally agreed procedures. So those are ISO 572 compliant, and it was actually done to the which is the protocol which is used by the AOAC and is recognized internationally as well. So the validation timeline actually started in August 2018 with the finalizing the in-house validation. That went on till July 19 for some methods. Sample preparation, however, was starting in January 19 and went on until August 2020. The pre-trials took place 2019. Workshops and feedback were in October, December 2019. And the trial proper were anticipated to start in early 2020 and to be finished by June 2020. However, of course, there was major issues to deal with, so that most of this got put back in terms of the final phase of the validation, so that we managed to get some validation completed June and July, and then others September and November. And for some methods, we've only just been able to finish them. And this, of course, is due to many factors, but the main reason that we've been able to finish this study is because the participants, the labs, have actually managed to do all this work despite their issues regarding COVID-19. So we're thankful to them. As I mentioned, a whole lot of test materials were made, and these were selected to be representative from range and type applicable to the method. The pre-trial, we sent out 1 or 2 samples to participants and asked them to analyze them and feedback. For the trial proper, we had 5 different sets of samples, but they were sent out as individually numbered blind duplicates. In other words, participants couldn't know that they were same sample. So the 10 were sent out to each participant for each method. And the sample preparation dispatch was done independently of the method developers and of the ourselves doing the statistics. And they were prepared and dispatched and randomly numbered by Ferroscience Limited, obviously in conjunction with us and the developers. So in terms of data analysis, the process that we used was that we, within the method, we made sure that there was some clear guidance or specifications for compliance. In other words, to make sure the method was being used properly. So all data was pre-screened to see whether the samples, the laboratories were compliant in using the method. The statistical analysis was then performed to internationally agreed protocols with removal of statistical outliers and final calculation of the method performance parameters. And feedback to the participants and developers is still ongoing with some of the late methods. As I mentioned, we had 2 technology transfer workshops at the end of the pre-trial. They were very well attended. These were mainly for the laboratories that were taking part. It's very much 2-way knowledge transfer, with probably the biggest transfer being from the participants providing information to the developers on sort of a critique of the methods as they were written. And without exception, for every single method that was looked at, improvements were made due to the feedback from the participants. And some of this feedback was very simple, things that we perhaps missed because we were too familiar with the method, that weren't so clear to the participants using them for the first time. So that a lot of improvements were made at that stage. So then we come, having gone through this process, we start the trial proper in finished. So the methods that were finally went through to the trial proper was the determination of polyphenols, that's by an array, a SPEMI GCFID method for free and esterified sterols, fatty acid ethyl esters methods, and a suite of methods looking at volatiles. And these comprise a targeted method using multi-analyte method using MS, and also a variant looking at GCFID, a non-targeted profiling method, and an assessment of the reference materials used for sensorial analysis. So these latter method, B and C, are very innovative, and there is no formal protocol on how to do this. So you'll be seeing results looking at really innovative approaches for doing this sort of work. And the protocols that I'm talking about aren't applicable for B and C. So you'll have to wait for the presentations from Stefania and Alessandra following my presentation to see what they've done. So in terms of laboratory participation in the trial proper, we had a good range of laboratories from Europe, US, and China. We had good participation in each of the studies, with 20 taking part in the fatty acid ethyl esters method, 60 in the polyphenols, and you can see the numbers there. So the minimum number that we really need for an international collaborative trial is 8, and we had, in most cases, we had a lot more than that. So all the laboratories, of course, participated for free, so we're very grateful for them, and all the data is anonymized, so that the data you're going to see, you won't necessarily, even if you're a participant, you won't know from the lab numbers, because they even change between the various methods. So you'll just have to try and recognize your data. Okay, so this is an example of the trial proper data for the fatty acid ethyl esters. As you can see, we had 20 laboratories taking part. We had 5 sets of blind duplicates. For this one, there was also a practice sample that was sent as well, which is a pre-trial sample. And so 20 laboratories. And this is looking at the data they send in here. So these are the various pairs. As I say, these are the duplicate pairs. So, and these are the from each of the laboratories. And this is just for one duplicate pair. So this is for 2 and 6. Samples 2 and 6. And I mentioned before that we screen out non-compliant labs. So I just wanted to show you this, because this, when you see the data, it might be slightly confusing. So we screen out non-compliant data prior to doing any statistical analysis. And non-compliance, as I said, means they haven't really followed the standard operating procedure. And for some laboratories, for instance, they just chose not to use the methods, and I think they wanted to see how their results compared with the standard the new method. Others perhaps didn't omitted to do one key part, so that they didn't do things either correctly or whatever, but they didn't conform to the compliance standards in the method. And you can see that they were made non-compliant regardless of how good the data was. So this sample, this lab 15 actually got quite good data, but it was just non-compliant. They hadn't followed the method. So whether a lab is non-compliant or not is regardless of the quality of the data. But here, this one is someone who has followed the method, but this time the statistical tests have identified this as an outlier, and this is because in this case they got a high value compared to the rest of the population. And this is just one pair of samples, so you can imagine the data analysis that we've done on all of those. So this is the typical statistical output that we got. So the NC this is the same data as the chart you just seen. So these are the 4 non-compliant labs. This is the outlier that was identified because the results are high compared to the others. And then this, once all that is done, the outliers are taken out, then we calculate the method performance parameters. So here we have a mean value of 49.3 milligrams per kilogram. We started with 20 labs, 4 non-compliant, 1 outlier. So we have 15 labs left on which this data is calculated. Important things to look at here is we have a reproducibility value of just under 14 for the mean value of 49, which is good. The RSDR is 10% for a concentration of 49. And here we have what's called a Horat value, which is a very rough approximation, but it relates the reproducibility values to the concentration that's being studied. And generally, a value between 1 and 2 is what we would normally expect for a validation study, a good validation study. But as I say, it's only a rough approximation. So here we've got a value just over 1, which is very good. So this for the same method, this is fatty acid ethyl esters that we tested. These are the full summary of results. So here we have the 5 blind duplicate samples, and these are the various parameters that we calculated for each one. And as you can see, the RSDR for these, highest one is 26%, but the lowest is 10. They're all good. And if you want to look at that Horat value, then they vary between 1.1 and the highest is 2.6. So that's very acceptable data in terms of an international validation scheme. So the next steps really, there's going to be some more results from the actual developers that will give you some insights into the work that they've been doing, and those results which are available, which ones, how they relate to the method itself, the purpose. Further data analysis is ongoing. We're going through the metadata still with the laboratories. We need to actually share results with the participants in terms of knowing how they particularly did. Then we need to formally finalize the data, and as Tulia was saying, we need to then propose the limits and ranges that are applicable. So I'd just like to thank all the project partners for the huge amount of effort. I'm presenting this, but actually huge amount of effort going into it. You can see it's a huge activity. And more than anyone else, I'd like to thank, on behalf of the consortium, all of the laboratories who took part in the studies under very difficult circumstances. So a big thank you from the OLEUM project. And I'd also like to thank co-workers, Tassos and Martina, who did most of the sort of liaison between all of the labs, the developers, etc., sample preparation, and a lot of statistical analysis. And thank you for your attention.